Welcome to Astro Morning Tea at ICRAR. I'm Greg.
And I'm Luke.
And we are going to be talking about fun science stuff. Let's go for the first story. Luke.
Great. There's a distinct lack of enthusiasm today, Greg. It's usually more exciting.
I think I'm like twice as enthusiastic
You will
as
be
most
excited.
people.
So, first, I'll do it. First story this week is about TESS, which is a planet hunting telescope which has taken its first images, which is pretty amazing. NASA have sent up the TESS satellite, which is the Transient Exoplanet Survey satellite, and it's taken its first images of a comet. Now, TESS is super exciting.
Hang on, is that what it's meant to do?
No.
Right.
TESS is super exciting. It's going to observe about 500,000 stars. And what it does is it looks for transiting exoplanets around those stars. So what happens is when the planet passes in front of the star, it blocks out some of the light. And that means that the light from the star dips slightly. And TESS can measure that and then work out the planets going around these stars.
So is it like sexy Kepler?
That's a very good description of it. Yes, sexy Kepler. So TESS should probably detect about 20,000 exoplanets and probably about 500 to 1,000 Earth-like planets as well. So it's very exciting. It's taken its first images and it's actually captured a comet flying across the sky over 17 hours. And it basically proves how stable the imaging is of the telescope and things. You can actually measure the tail of this comet and things. So it's super exciting.
That's fantastic. When they find these Earth-like planets, can we claim them? Can we go, we'll have that one.
For Greg. We're back to Greglandia again.
Greglandia!
Yeah, you should go.
Excellent. So we can claim one?
Yes, yeah, you can. Personally,
okay.
Go.
Good, I will. Fantastic. So once I get to my new planet, what will be the next story I'll hear on there?
Yeah, but it's very exciting that over the next few years we should be detecting loads of these Earth-like planets. So the whole field of extrasolar planets will be carrying on to increase dramatically.
What we've discovered about 3,600 or so.
Rapidly going up all of the time.
Oh my goodness. Planets are everywhere. They're just like dust in the wind. Ridiculous things.
Just musing on planets.
Yeah.
Very poetic, Greg.
Thank you.
The next story this week is about scientists using YouTube videos of students to do their science.
That's not creepy at all.
That's not creepy, no. This is the story about craters, impact craters on different planets. When you see, on the moon, you see lots of craters and all these holes where bodies have hit the moon. And some of these craters have rays that shoot out from them, so straight lines that fire out away from the crater. Now, it's kind of puzzled scientists as to how these rays that shoot out are actually produced. So when you try and study these craters in the lab, you actually take, layers of sediment that you build and you fire ball bearings into them really quickly.
Which just sounds like the best job in the world.
Yes, yeah. What do you do? I shoot sediment.
I fire ball bearings at dirt and then measure it.
Yeah.
Cool.
It's cool. Yeah, why not? But they haven't been able to reproduce these radial lines in their experiments in the lab, and they didn't know why. So they actually went to YouTube and they actually looked at lots of experiments of students actually reproducing this. So lots of students within their physics classes actually do this experiment, and they found that some of them produce these rays and some of them don't. And then they looked to see which experiments produced the rays and which ones didn't, and they found that the distinguishing feature between those was actually using a bumpy, non-uniform surface that you fired it into. So they went back to their lab, they used a bumpy, non-uniform surface, and they could then produce these rays going out. So this is really important to learn about early collisions in the solar system and how the solar system was formed and things like that. But they actually turned to high school students on YouTube to find the answer, which is pretty amazing.
So professional scientists are stealing the work of students to write their papers.
Yeah, we'll steal the work from anyone, Greg, if it gets results. Don't worry, we're always round. I'm always sneaking a look at what the students are up to. Then I'm off writing a paper.
Well, about stealing work, let's go steal Ronnie Joseph's work when he answers the question, where do comets come from?
So where do comets come from? Well, to look at that answer, we first need to understand where do stars come from. And stars are formed when a big cloud of gas full of pebbles, ice, rocks, collapses and forms a star. Part of the gas also forms planets, like our Earth, but lots of it just remains out there, standing still, doing nothing, just ending up being there forever, until one of our planets and its gravity pulls one of those rocks in, and we're talking really big rocks, and those rocks fall closer to the Earth, and as they get closer to us, they get closer to the Sun, and they start evaporating, creating large plumes of gas and ice out there, which are illuminated by the Sun, giving these amazing sights in the night sky.
Thank you, Ronnie, for answering the question about where comets come from. But you know what I really need?
Do you really need?
I really, really need a random fact.
Oh, well, I'm happy to provide.
Excellent.
So the random fact of the week this week is, Greg, has an alchemist ever made gold?
No. Because
No.
alchemy's not a thing.
It's wrong, Greg.
What?
So, alchemy is the idea of turning other materials into gold.
Yes.
Humans have basically had this idea for thousands of years, basically. This idea that you can take something that's not very valuable, turn it into gold, and make loads of money.
Base metals. Into
And
wonderful metals.
the first scientific approach to this happened in about 400 AD, I think it was, when they started making
Scientific
gold-like solid objects. Yeah. But all through history, people like Newton and Boyle and things have all tried to do this.
And why wouldn't you? Let's
Why
face it.
wouldn't
If you're
you?
like
That's true.
Well, I'm the top scientist of my age. Everyone loves me. I think I'm going to
Let's
turn
make
everything
some
into gold because I want to be
Everything into gold.
I'm going to be rich.
But this leads us then to the 20th century and a chemist called Glenn Seaborg. Now, Glenn Seaborg was a pretty amazing chemist. You may not have heard his name, but he did some amazing things in the 20th century.
There's an element named after him. Isn't it Seaborgium?
You're on the ball, Greg.
sorry.
Amazing.
Am I preempting this story?
No,
I'm sorry.
No,
good.
it's fine. So he basically is the only person who's ever had an element named after him in his lifetime and used it. He also in 1941 was part of the team, led the team that found plutonium and produced plutonium.
Named after his dog.
Terrible. Then he worked on the Manhattan Project as well. And he actually, amazing guy, he discovered 10 elements in his lifetime.
Oh, wow.
And over 100 different isotopes. And he actually found the isotope of iodine that's used to treat thyroid disease today. So if you're being treated for thyroid disease, you have him to thank. So an amazing guy. But in the
Dr. Seaborg.
1980s, he was part of a team that actually used a particle accelerator to fire carbon and neon nuclei at bismuth.
Right. As
You
you
can see
do.
where this is going. When they looked through the remnants of this, they actually found that there were a few gold isotopes in the remnants. So they actually, from carbon, neon, and bismuth, produced gold. So the first time after thousands of years of trying, an alchemist, Glenn Seaborg, had produced gold. Now, he does point out that this isn't very economical in terms of producing gold because he said producing gold this way for 1 ounce would cost $1 quadrillion. And at the time when he did it, 1 ounce cost about $600. So not too profitable, but he actually did it. The first person to ever do it.
I'm going to claim rubbish because it's not alchemy. It's just nuclear fusion. And that's not alchemy.
It's still alchemy. You just need a particle accelerator to do it.
You need to really open the definition of alchemy. I'm angry about that. You made me angry. And with that bombshell of my rage...
You're always angry.
I'm always angry. That's my secret. Me and Dr. Banner. Basically, thank you for watching Astro Morning Tea at ICRAR. Join me again, Luke, in the future, and we'll do some more.
I will join you, Greg.
Thank you.
Thanks.
And you should join us too, listener. Thank you very much.